Okay, so let's go ahead and do a 2D projectile motion problem. So in this problem, we want to find the maximum height of an object that's been launched. So let's go through this and figure out the maximum height. So we have an object that is launched an initial velocity of 35 meters per second at an angle of 30 degrees from the horizontal. So that just means an angle up from the ground. If this object is launched from the ground level, what is the maximum height? So let's go ahead and draw out this picture first. So here's the ground. We have our object being launched at an angle from the ground. So here's our angle. It's going to follow this trajectory and fall back to the ground. So what can we say we know here? We know our initial velocity, so this is the magnitude of the initial velocity. That's 35 meters per second. We know that this angle here is 30 degrees, and we know that it's going to reach this maximum height here. We're going to call that h max. And so because this is launched at an angle, it's going to have an x and y component of the velocity. And that's what makes it a 2D problem. So we have Vx and Vy. So Vx is just going to be the magnitude of the velocity, V initial, times the cosine of the angle. And Vy is going to be V initial times the sine of the angle. And in a projectile motion problem, the object is going to, so it's in a free fall motion, it's only being acted upon by gravity. So it's going to go up to its maximum height, and then its y component of its velocity at the maximum height is actually 0 meters per second. And then it starts going in the opposite direction and falling downward. And the x component of the velocity is actually staying the same the entire time because it's not acted upon by gravity in the x dimension, only in the y dimension. All right, so which of these equations over here can we use to solve this problem? We don't know the time, so we're not going to use any of these with the time in it. We do know the initial velocity. We know that the acceleration is the acceleration due to gravity, g. We want to find the maximum height, which is a distance. And we know that at that maximum height, which we can call v final, that is 0. So let's go ahead and use this equation. So we have v final squared, and this is in the vertical direction. So we're looking at our y components here. So v final y squared equals v initial y squared, and then it's going to be minus 2 times g. So it's minus because g is negative. The acceleration due to gravity pulls downward. And then we have our d, which in our case is just going to be the h max. So at h max, we just said the final velocity is 0 at that point. So plugging in our v initial sine of theta for our initial velocity, we get v initial sine of theta, and we square that, and then we have 2g h max. Now we need to solve for h max, right? So let's add 2gh to the other side and then divide by 2g, right? So that's going to be h max equals v initial sine of theta, all of that is squared, divided by 2g. Now we have our equation for our maximum height. We just plug in the values that we already know, and we'll get our answer. So this is going to be 35 meters per second times the sine of 30 degrees. This is squared. And we have 2 times g, which is just 9.8 meters per second squared. As long as we are at the surface of Earth, g is always going to be the same in these problems. So go ahead and plug this into the calculator, and we're going to end up with a maximum height of 15.6 meters per second. However, if we look at the other values that were given in the problem, these all have two significant figures, so we'll go ahead and round this to 16 meters per second. And that is our answer.